know in the. Yeah. You are living, yeah, yes, here, maybe. Roberta is here. Yeah, yeah, so we see. Maybe because like we will have not so many people, so we can. Oh, okay, free. Okay, we can. Yeah, but it's so easier. Maybe you. I don't know. And for live streaming, it will be how it's live streaming. There is a camera. Camera is some. Okay. And how it works? It works like that. No. I don't have it. So it works. Yeah. So good afternoon, ladies and gentlemen. Welcome to the event on strengthening transboundary water resilience on the example of Guarani Aquifer management in Latin America region. I'm Yulia Vistovna, Senior Water Program Officer from International Atomic Energy Agency. And today, we, together with UNESCO and government of the Brazil, we prepared this event on the Guarani Aquifer as example. To open the event, I would like to start from the opening remarks of the Ministry of the Environment and Climate Change in Brazil, Mrs. Yara Giacomini. No, it's okay.
Ladies and gentlemen, esteemed delegates, thank you for the opportunity to talk about the Guarani Aquifer, and doing so, help to make this invisible giant visible to the world. My name is Yara Giacomini. I am the Director of Water Resources from the Ministry of Environment and Climate Change of Brazil. And in an era where conflicts over natural resources dominate headlines, it's truly a privilege to stand here as part of a transboundary cooperation for the water. The Guarani Aquifer Treaty is a shining example of what can be achieved through collaboration, mutual understanding, and trust among nations. Since 2020, after being ratified by all the 4 signatory countries, Argentina, Brazil, Paraguay, and Uruguay, this agreement has served as a cornerstone of water diplomacy. It's a source of pride that the treaty reflects the values of the South-South cooperation, bringing together to protect and manage one of the world's largest groundwater systems. Guided by the best science available, we have worked to ensure that the Guarani Aquifer remains a secure and resilient source for millions today and for generations to come. The Guarani Aquifer Treaty is more than just a legal instrument. It is a testament to the power of multilateralism. It underscores the importance of regional collaboration to address global challenges. It demonstrates how science, cooperation, and a commitment to sustainability can create solutions to pressing issues like water scarcity and climate adaptation. As we gather at COP29, let's celebrate this milestone while recognizing the work ahead. By continuing to support frameworks like the Guarani Aquifer Treaty, we can inspire similar cooperation across the globe. By fostering water diplomacy and grounding our efforts in scientific knowledge, we can protect the lifeblood of our planet and build a future where water is a source of peace and resilience. I wish you a very great session and debate to keep making the invisible giant giant. Thank you very much.
Thank you very much, Yara. And we are sad that we are not here with us in person. And I would like also to highlight what Yara actually been one of initiators of this event. Now I would like to invite Ms. Ruth Nguma, the program specialist from UNESCO, because this event also done together with UNESCO, and she will highlight us how international cooperation important, especially if you are considering transboundary aquifer, transboundary waters in very complex systems. So please, Ms. Ruth, the floor is yours. I think we can, because of sound background,
Okay, thank you. Okay, thank you. Can you hear me? Okay, thank you. Now, as you've been told, my name is Ruth Nguma from UNESCO, and I would like to talk about the importance of international organizations. And as you know, UNESCO is an international organization, and we have the convening power with 194 member states, and with the convening power, we are able to bring about coordination and also bring about the collaboration between different stakeholders. And in that sense, I would say I would like to zoom in into the Intergovernmental Hydrological Program, which I work under, and we have like 3 mandates: improvement of science, and we set the agenda for scientific development and implementation, and that has to do with translating science to applications. That's how we support development of tools, methodologies, and we help member states to be able to apply them and even integrate them in their policies. Another mandate that we have is to build capacity of the member states and education, because you need education and you need the capacity to be able to implement the science that has already been established. That's why we have the capacity building and education mandate to support translation of science to applications on the ground, because you need to be equipped for you to be able to understand the kind of science that you're translating. The third mandate of IHP is to support in linking science and policy. So we support member states in and do the advocacy of making sure that they adapt their policies underpinned by scientific evidence, because that is what we need for us to be able to bring the profile of science, especially in water, to bring it to a level that we can rely on science for us to be able to make the decision. And now, as you have heard Ihara, who has already talked about is it Guarani Aquifer? I don't know whether I'm pronouncing it well, but it's the third largest aquifer in the world. And this is a very huge resource of water, and also we need to be careful on how we manage it, because because being a shared resource, of course, you need cooperation, and that's why there is the need for transboundary cooperation, and we need to enhance how we can be able to share this resource together and also share it in a way that it's a just cause for everyone who is involved. And for that reason, this aquifer is benefiting from a UNESCO project, and this project is the Aquifer Strategic Action Program, which has been running from 2022, and it ends this year. But I guess maybe there will be some extension. You know, most of the projects do not end at the right time because of some factors and the many stakeholders that are involved. So it's a J-funded project with around $200 million US. And it focuses on transboundary technical cooperation. So that's where UNESCO also comes. Yes, we have different technical capacities, but we also need to cooperate and create synergies so that we may be able to address the challenge that is facing this aquifer, and that we may be able to use the resource in a sustainable way. Because if we look at our own interest, if you look at your interest, I look at my interest, we cannot be able to do anything. Otherwise, everybody will be over exploiting, and at the end of it all, will not be having any resource. But if if we cooperate and create synergies and also agree on how we are going to share this resource, that is a very important aspect to consider. And then it is going to, the project also looks at the regional multipurpose harmonized monitoring network. Because another thing, you cannot be able to use that which you cannot measure. Imagine even in your own house where you have like even some sugar or some flour, you need to know how much it is for you to be able to use it appropriately and to plan for the week or even for the day. So that's why it's important for us to have a monitoring network for us to be able to understand the resource, to understand the amount of the groundwater that is existing and how we can be able to share it among the stakeholders. And it's not just from one side. We need to consider it from all those that are sharing the aquifer. And as you know, it's not easy. When you consider groundwater, the monitoring of groundwater has been lagging behind. Yes, it's a resource which is both an opportunity and also it presents an opportunity for it to be overexploited. And this one needs more monitoring because most of the places, even in the world at large, we have limited monitoring network. Yes, we have satellite data, but as you know, satellite data, it has its own limitations. That's why you need in situ observations for you to be able to integrate the in situ observations together with the satellite data and for you to be able to make informed decisions and also be able to feed to your policy framework. Also, the project aims at enhancing stakeholder engagement. And when you talk about stakeholder engagement, it's very critical because we need to co-develop the strategies and adaptation strategies for the whole aquifer. So we need the stakeholders. And you cannot just come outside and tell the stakeholders, this is what I'm going to do. You need, first of all, to understand their problems and make sure that you are on the same page, understanding the problem from one perspective. And that is what UNESCO is supporting the project to be able to do. So we are doing this through the stakeholder engagement and involvement through the strategic action program of this Guarani aquifer system. So we need to consider, as I conclude, we need to consider inclusiveness, inclusivity of even the local people, people with the indigenous knowledge. I cannot just come from UNESCO just because I have this high level of scientific understanding or even from my hair. I need to come and also understand the indigenous knowledge and also to be able to collaborate with the people that are at the grassroots and make sure that we understand each other. And perhaps we can even think of integrating all the knowledges for us to be able to address the challenge that is facing this aquifer. So, as I will conclude by saying that, yes, for UNESCO, we play the role of convening. We have the convening power, and also we support the collaboration of stakeholders and also bringing member states together because we are one body with all the member states, so we can talk to all of them, even when they are not talking to themselves at the grassroots. So thank you.
Ruth, thank you so much. Thank you. I think you highlight all important points related to Guarani aquifer and even beyond related to groundwater. Because particularly me, if we are talking about aquifer, I cannot see it. Exactly, I cannot see simply aquifer. If I go to Transboundary River, I can see Transboundary River. And I can understand what part of the watershed relate to which country, yes? But with aquifer, it's not easy. We cannot easily identify all places, all countries who can benefit and who can less benefit or who can more benefit. And for that, we need science, we need more data, as you absolutely correctly highlighted for us in this event. So we need to understand more how it's functioning and how we can share this resource. Because also we see, like in our program, we also see what the role of groundwater is growing. So we have more and more countries, they become independent on groundwater. And before they've been dependent more on surface water, but because of the droughts, and we know in Latin America we experience quite a lot of series, and long-term series of the droughts, yes? So aquifer becoming only, probably sometimes, only resource what we can use.
Sure.
Yeah, so thank you so much. Also, thank you for highlighting this UNESCO contribution. And we can see what in this complex system, we need a lot of collaboration, not only between different countries, but also between different international agencies, what we are attempting to do, and we are doing it successfully sometimes, and we will improve it in the future.
Exactly.
Thank you, Ruth, so much. So When we are talking about Guarani Aquifer, definitely we need to understand more where it's located, at least on the map, how is the geological structure and how it is used. So for that, I would like to invite Dr. Roberta Kirchheim. He is Director on Hydrology in the Geological Survey of Brazil. So he will make us a presentation about the Guarani Aquifer more in details, but we can see the overview and also the country.
Hello everyone, I am Leticia Rodriguez, a full professor.
Are you hearing me? Okay. So
Thank you so much.
I will need the presentation. So it's a pleasure to be here. Thanks UNESCO and the agency for being me here. Are you really listening to me? Yeah. What I'm going to present to you in a very short way, it's an example of a synergy and how did the cooperation brought very good results in this place of Latin America where the Guarani Aquifer system is lying. So please, next one. Okay. So those here are the main institutions that are supporting this event. Let's move forward. So it's very important to keep in mind that to do a better management, we need reasonable data. So we cannot turn around this figure by trying to do water management just like it is right now, because otherwise we are going to make a lot of failures at the end when it comes to management. So to take the right decision, we have to build strong and robust data at the very bottom of the project or at the initiatives, and then keep moving in terms of gathering more and more data, exchanging data with neighboring countries, because this is a transboundary aquifer, and at the end to achieve and to respond to the society, because everybody is looking for this piece of water, and it's a place that is growing very fast, agriculture, industrial, and also because of the rain pattern has been changed a lot in this region. We are very, very susceptible for this climate change effects. That's why groundwater is going to be, people are going to look for groundwater even more and more and more. So why the Guarani Aquifer system was chosen for this cooperation efforts. It's a major transboundary aquifer system. It was the target of many research initiatives. It was the first global environmental facility project on groundwater management, so it was a pilot project for the GEF. On that time, it was a World Bank project as an implementing agency. The Organization of American States have the executing agency plus the 4 countries sharing it. We finally got to a treaty, which is one of the few aquifers, transboundary aquifers in the world where there is a treaty. So it's a kind of a huge responsibility to keep on going. So it's a place where there is an intensification of the use of the confined areas, as we are going to see. And like our UNESCO representatives just said, it is we have there an ongoing GF UNESCO project. And the agency has supported a huge effort in terms of the use of isotope tools for better understanding the water dynamic of this aquifer. So let's move. So this is more or less where the aquifer is lying in the South American continent. As you see, it's a huge transboundary area, and comprised of Argentina, Brazil, Uruguay, and Paraguay. The biggest park is lying in Brazil, and it's interesting to note that on the blue areas is where the water is recharging. And the recharging occurs on the border of the aquifer, and it flows towards the center of the basin. It's a geological basin where the water can be, so this is the aquifer. The water is covered by a huge pile of basalts. So in the center part of the Guarani Aquifer system, we are talking about a confined aquifer where the main question is how much recharge can we apply for that area? How many time does it take? What about the residence time of this water? Are we mining this aquifer system, or the replenishment rate is very high? So those were the questions that we would like to address by using isotopes. And here's some pictures about the scenario of this aquifer, but this is the most important idea. It's a pretty much confined area. It's a confined aquifer. So this is the information that we had before the engagement of the International Agency of Atomic Energy. So we knew that with carbon-14 ages, all the ages were like 40,000 years. But 40,000 years for carbon-14 is the limit of the method. So we knew that probably this water was much older than those 40,000 years. So therefore, we needed some new isotopic tools to get the real residence times. And by having the residence times, we can do a better management. So this is the strategic action plan that the representative of UNESCO talked about. In fact, I'm the author of this piece. I was the one that wrote it, so I'm pretty aware of all the international efforts that were going on since the last 20 years. And this is the original draft of the project appraisal document that we wrote with the World Bank on back time. So this is more or less, by using isotopes, we changed the whole idea of how this groundwater system worked. At the beginning, it was supposed to be homogeneous and not very difficult to understand, but at the end, by using isotopes, we were able to have some 4 blocks, which we call domains, and then we realized that some tectonic structures that influenced a lot the groundwater flow on regional terms, and also because of this application of isotopes, we were able to understand then the paleoclimate by using stable isotopes and comparing those groundwater data with GENIP data, which is the groundwater, the monitoring network for precipitation in isotopes, also run by the agency. So, and then we realized that despite the huge volumes of groundwater stored in the Guarani Aquifer system, its recharge rates are considered very low. So this is the main challenge, how to cope with a growing use, realizing that the recharge is very low and that the water is very, very old. So at the beginning also people realized, thought that the aquifer was very homogeneous, but then when we looked into detail, we realized that it's very heterogeneous and that the water, in fact, moves in a different ways. So by doing this field campaign that I did this by myself, I mean traveling all around and taking noble gases and krypton samples for producing the residence times, supported by the agency in different coordinate research projects, as you can see in the slide. So by speaking about tracers, it's very important to understand that we are talking about krypton-81 and argon and also noble gases, which are tracers that can help us understanding very old groundwaters. So at the end, by doing lots of things, using mathematical modeling, field campaigns, we were able then to identify those very old residence times on the Guarani. As you can see here, we are talking about million years old residence time, 7,000 years resident times. And when you have the residence time and you have the hydrochemical fingerprint of the water, you can understand a lot about how the groundwater evolves when flowing from the recharge areas to the center of the basin. So this is where we are right now. So this is a map showing the residence times, the brown areas. It's very old water, green and yellow, not so old. And so we are building mathematical modelings coupling krypton-81 with noble gases to better understand the ages. And those are the targets of the campaign that is going to take place in 2 weeks, where we go to the field again, take samples, and produce new data. At the end, what we want is that the countries, they understand that they are I mean, they can use this water. It's a strategic reserve, but they have to understand they are also mining this water. Recharge rates are very low, and residence times are very, very, very high, are very big. So it's a matter of decision. What we want to produce is the best data available so that they can take this decision on reasonable terms and thinking about sustainability. This is a map. I showed a lot of maps, and this is a map done by a farmer in South Brazil. When I went there, I was looking for groundwater wells and also some ponds. And then the guy who did this map, he was the driver of the kids to the school, and he said, no, wait 10 minutes. And he did this map on his community, pointing out every single house with names and if the house had a groundwater well or a pond back in the garden. So then I was like, after 30 years working PhD in hydrogeology, I realized that we have really to trust on people and to work with them because they have a knowledge that we don't have. So by saying this, thanks a lot. I don't know if I'm on time, but I try to rush as much as possible. Thanks a lot.
Thank you very much, Roberta. Actually, it's very interesting to hear about in one aquifer, we have different age of water, different mixture of the age of the water, and this water ranging not from 1 year to 10 years, but to 1,000 years. Maybe, I don't know, maybe dinosaurs been drinking a Guarani aquifer at that time. I don't know, we need more investigation on isotopes here to discover it. But Guarani aquifer is a transboundary aquifer, and we have more countries involved who unfortunately cannot be present with us here in person, but they recorded video. So I would like to invite the Professor Leticia Rodriguez from National University of Litoral in Argentina, who will share experience of Argentina and study the Guarani aquifer. Thank you. It's video.
Rodriguez, a full professor at Universidad Nacional del Litoral, Santa Fe, Argentina. I've got involved in SAC-related research projects for more than 15 years, since 2004, in things related to hydrochemistry, hydrogeology, but mainly groundwater flow modeling. Since the beginning, I participated in multidisciplinary teams integrated by engineers, geologists, hydrologists, geophysicists, and others that brought diverse and rich views into the projects pursuing a single goal: to contribute to the advancement of knowledge of the physical environment of the Guarani aquifer system for its sustainable use and management. The working experience has been very enriching to me and included working with professionals from Brazil, Paraguay, Uruguay, Argentina, and Spain, with the financial support of international agencies as well as national science ministries from Spain and Argentina. In the process, I met colleagues, but also I made a lot of friends. In the technical process, environmental tracers as well as hydrochemical tools combined with other tools, have greatly contributed to development of conceptual hydrogeological models on how the flow system works. However, there are still technical as well as institutional issues that need to be addressed in the future at different spatial scales. On the technical side and at regional scale of the entire aquifer, we need to integrate hard and soft data into a new conceptual model of the Guarani aquifer system to elucidate, for example, the issue of the northern-southern hydrogeologic continuity and to reevaluate the location as well as the magnitude of the recharge the aquifer is receiving, among other issues, of course. At sub-regional local scale within the southern sector and the Argentinian territory, we need to collect more data. data on geology, water levels, hydrochemical data, as well as environmental tracers. Later, to integrate all these data to recalculate or calculate groundwater age. And all that background and new data must be incorporated into a new understanding on how the system works, later to be tested with groundwater flow modeling, incorporating this time the groundwater age simulation. We hope that the outcome of these new efforts could help us to better identify discharge as well as discharge areas of the aquifer into shallower aquifers or surface water bodies located within the Argentinian territory, and if possible, estimate their magnitude. On the technical side, at regional scale, we need to recompose multidisciplinary, multinational collaborative teams to address many pending issues. And on the local scale, I could concentrate in two main issues. First, to better train the technical staff of SAC Argentinian provinces to transfer and convert the existing and future knowledge of the SAC into better groundwater management practices. For example, to incorporate the concept of non-renewable groundwater resources. Second, to reach out water managers and funding agencies to get more human resources involved and get more funding for research. Finally, no doubt that future climate change scenarios must be incorporated into the analysis all across spatial scales to develop strategies to face the increasing pressure over groundwater resources. And thank you all for your attention.
We would like to thank Letizia for your comments, and I would like, because she's not here, so please, Roberta, can I ask you?
Sure.
She mentioned about international collaboration, and it was one of the important points to collect data. Please, can you give several short examples how your countries who sharing with Aquifer collaborating together?
Yes, for
Are
sure.
you doing sampling campaigns?
Yes. We did several field campaigns together with Argentinian friends. So Leticia is a good friend of mine, a good friend of ours. And at the beginning of the project, there was people didn't know each other, and every country was trying to save her own its own data and not sharing, because, well, why we are going to share our Brazilian data with Argentinian friends or Paraguayan or Uruguay? So we had lots of discussions just to realize what the aquifer is, what are the rocks we are talking about that belong to the so-called aquifer system. So this is 2 years of discussions, heavy discussions with geologists, geophysicists, and whatever. So after many meetings, and especially when we went to the field together, drank mate together, and got some beers together, at the end we just realized we have to share information and to cooperate. So all this work done, supported by the agency with noble gases and krypton, was done in Argentina, in Paraguay, in Uruguay, and sometimes I'm being Brazilian, went to Argentina to do the field work or the opposite. So this is a good example on how things should be. Without UNESCO, without the agency, we are friends. We are going to support each other anyway. So on academic level, there is a lot of things, very positive things going on. I think this answers the question.
Yeah, thank you very much, because it's always interesting to know how in such complex transboundary situation is solved inside and between the countries. And I would like to invite the, unfortunately on video and in person, Gerardo Viraslavsky. He's professor from University of Uruguay Republic, and he is one of also who is collaborating with your team on the Guarani Aquifer. So he can share his experience from Paraguay, Uruguay.
It is an honor to participate in COP29 to discuss the Guarani Aquifer system. The Guarani Aquifer system is crucial for my country. It is main underground freshwater reserve in Uruguay. My name is Gerardo Veroslavsky. I am geology and full-time professor at the Faculty of Science. I am also responsible to training geology students at both undergraduate and postgraduate levels. My expertise focus sedimentary basin and basin analysis, especially regarding in natural resource. For over 20 years, I have studied the rock formation that contain the water of the Guarani Aquifer system. I have collaborated with interdisciplinary research group from Brazil, Argentina, and Paraguay to develop a conceptual hydrogeological model that explains how the Guarani Aquifer functions. I would like to emphasize that much of this work has been made possible through international cooperation. Many of these efforts have received support from international agencies such as the GEF, World Bank, and International Atomic Energy Agency, and additional support has come to university cooperation programs between our countries. In recent years, new research has important advanced our understanding of the Guarani Aquifer system, especially progress in hydrochemical and isotopic studies. Some questions remain open, and addressing them is essential to deepen our knowledge and support collaborative efforts for more effective groundwater management. Continued international cooperation is crucial for creating technical frameworks that sustain collaboration among Argentina, Brazil, Paraguay, and Uruguay. The agreement signed by our country is the starting point for this cooperation, for international cooperation. In recent years, in Uruguay, we have made significant progress. The Guarani Aquifer has an interinstitutional commission and approved management plan in 2024. But several technical aspects for sustainable use and management still requires study. In closing, I would like to outline some key challenges that call for international support and collaboration. These include both technical and institutional aspects. Technical aspect. 1. Water monitoring and acquisition of new geological, hydrological, and isotopical data. Number 2. Modeling and prediction, including the development of conceptual and numerical models for scenarios such as climate change and land use change. Number 3. Pollution and water quality. Institutional aspect. Number 1. Coordination among the government on the involved country. Number 2. Advancing of legal framework for collaboration. Number 3. Establishing community structure that encourage citizen participation, especially in transboundary areas. Thank you very much.
So thank you, Gerard. And here I would like to ask our guest, Martin Krause, from Director of the Technical Cooperation of International Atomic Energy Agency, because Gerard, he mentioned very important aspect about technical cooperation, institutional cooperation. Please, Martin, can you give several words to us about how agency, how technical cooperation department support South-South cooperation, what we can observe here in Guarani Aquifer case study?
Yeah, thank you. Thank you very much, Julia. I'm very encouraged to hear the testimony of colleagues who have been working in this field for so many years, from the 4 countries that are part of the Guarani Aquifer. I'm encouraged because I'm sitting at the IEA in the Technical Cooperation Department, and we have several modalities to encourage transboundary work, coming from the recognition that nature is transboundary, and in particular water is transboundary. We have several instruments that are at the disposition of our countries to use them. So, for example, we have a regional cooperation agreement in Latin America called ACAL. That is an agreement between the Latin American countries to work together when it comes to nuclear techniques and nuclear technologies, and especially to address problems that go beyond the national boundaries, such as is the case here. So ARCAL is such a, what we call a South-South collaboration mechanism. And what that means is it's actually institutionalized. There is a structure around that. So if you have a transboundary water issue that you want to address with the help of the IEA, you could go to ARCAL and suggest a project. And then ARCAL takes it to us, and according to the criteria that we have and so on, we could look and approve and fund, with grant funding, we could fund such a project. So that is a very, relatively, I would say, easy mechanism to support the work that the countries within their national institutions are doing anyway. So the ARCAL as a regional South-South collaboration mechanism is one of them. The other one, and I think Roberto, you have mentioned it, CRPs, the coordinated research projects. It's another modality that the IEA has to support countries who want to advance the national research that is done in the various institutions, but to include then nuclear techniques, isotopic techniques into the research that is going on in the ground. And CRPs, is also relatively, I would say, easy mechanism to access. And that is available to the countries. We have in each country also a so-called national liaison officer, which is kind of a focal point within the government structure, through which countries can access these kind of collaboration mechanisms, including funding, grant funding. Roberto, you have mentioned the GEF, the Global Environment Facility. They have the International Water Program. It's also a very powerful program to address these transboundary issues. The Guarani maybe was the first one. Then later, when I was working in other regions, I know in the Sahel, they have also worked, both the GEF and the IEA, with 13 countries in the Sahel to do similar work, to assess, underground water resources using isotopic technologies. I think the Guarani Aquifer is the most powerful example because you have not only done the scientific work, you have translated it into a strategic action program. That is much more than doing the science and mapping and driving around in a 4x4 and digging and looking. It's much more. It's actually bringing the science to the policymakers, right? To translate science into action, using the SAP, I think you mentioned even a treaty you have done. So that is a very powerful result, I think, and it shows of what can be done if we properly connect science. UNESCO has collaboration mechanisms, we have heard. IEA has it. If we connect that in a meaningful way, I think there's a lot that we have done that we can do. And that is kind of the message that I want to bring here also to this side event. Thank you.
Thank you so much, Martin. Thank you. About highlighting water management and management, we always should consider how we can translate scientific data to management and how it's linked to different but scientific by decision based on real scientific data. Thank you, and I would like to invite online His Excellency, Mr. Facchetti. He is former Ministry of the Environment in Paraguay, and so he will tell a little bit more how data been translated in the management.
Dear Dr. Kirchheim, distinguished panelists, ladies and gentlemen, thanks for inviting me to participate in this important side event at the margin of the COP29. I am an environmental scientist, academic, and policy expert, with a career in the field of isotopic hydrology, environmental chemistry, and sustainable water management. My work has focused in understanding of groundwater systems in Paraguay, with a particular focus on the Patiño Aquifer and part of the Guarani Aquifer. The results of my work has also contributed to the creation of national policies that promote the sustainable management of natural resources and environmental protection. My experience with isotopic hydrology dates back to the early 90s. In 1994, while serving as a superintendent of technology at Paraguay National Water Works Company, I initiated a pioneer project to study the isotopic composition of groundwater and rainwater in Paraguay in collaboration with the International Atomic Energy Agency. One of the research focused on determining the age, origin, and renewable rates of groundwater in various aquifers, including the Guarani. The result of this research was presented at the International Conference on Isotopic Hydrology in 1995 and laid the foundation of further studies on the aquifer's sustainable management. In 2000, being Minister of Environment, I requested to include this technique in the proposal to study the Guarani aquifer, and as a result, it played a key role to better understand the aquifer, and the agency became an important partner in this project. At the same time, when we discussed the National Environmental Strategy, I realized that the challenges facing the environment couldn't be solved by individual nations alone. I realized that global cooperation was essential for addressing complex issues that transcend borders, especially for a large and transborder aquifer as is the Guarani. This project is a good example of how international cooperation can create a positive and synergetic impact, not only among countries with asymmetric capacities, but also with international organizations like their agency and the Federal Institute for Geosciences and Natural Resources. Recognizing the shared responsibility for its preservation, our countries came together to design and implement a collaborative strategy for sustainable management, improve scientific understanding, and foster long-term conservation effort of the aquifer. One of the critical lessons from the project is the importance of cooperation in achieving sustainable water management across borders. Thus, the project emphasized the creation of joint frameworks for resource management, shared data collection, and collaborative research. The project also benefits from partnership with international organizations like the agency and the BGR. The agency contributed expertise in environmental monitoring and the safe use of nuclear technology for water resources management. Isotopic techniques were used to trace water movement and identify potential contamination sources. The BGR provided technical knowledge in hydrology, geochemistry, and resource management, helping to ensure that scientific data and recommendations were based on the latest research. The synergy created with these international organizations illustrate the importance of cross-sectoral collaboration and also demonstrate that when countries and international organizations cooperate, they can amplify their impact, creating a multiplier effect that advances global sustainability goals. The collaborative model used in this case highlights how shared resources and expertise can lead to more robust, lasting solutions to complex environmental challenges, providing that cooperation is key to addressing the most pressing issues of our time. Thank you, and I wish you a fruitful participation at the COP29.
So, thank you, His Excellency Fassetti, for finding time and record us this important message. Because, Roberta, again, you are here with us and you can answer many questions. I have just 2 questions for you at the end of our event. Because His Excellency Fassetti, he mentioned institutional and legal frameworks. They are necessary to support the sustainable water management of the Guarani Aquifer. Can you give example what institutional and legal frameworks are necessary to do that? At present time, or maybe experience what's been done in the past, lessons learned or successful stories what you can share?
It's very important that the countries, they have sufficient strength to cope with these issues. If you talk about Brazil, Brazil has the water belongs to the states, and every single state has its own water management institution. So all those maps, all those information that is being produced through cooperation, they have to be to disposal to the technicians that are asked to do the management or to give the permissions for new groundwater wells or not. So this is in the case of Brazil. This is the case of Argentina, where you have the provinces that they also own the legal issue of giving permissions for new users. And Paraguay and Uruguay, it's a more, they are not comprised, they are not, the legal issue is more on the federal law, but they have the same challenges. So all the information must be there, and we have to work at the same time, gathering new information, producing maps, producing modeling, producing monitoring schemes, but at the same time, we have to guarantee that at the end, the countries, they do have this institutional strengthening for answering the questions that the society is posing on a daily basis. Because demand are rising continuously. And all those questions, imagine that you yourselves, you are working on that level, and every day 10 people come to ask you, can I drill a new well? Can I extract new water for my irrigation scheme that needs lots of water? So they have to have all this information in front of their hands so to take the right decision. So this is the huge challenge that we are facing right now. Despite all these efforts, we have to guarantee that at the end, the information is there where it's needed, so that the countries, they can take the good decisions.
Thank you, because you shared with us also this map what been drawn by local people. So generally, this is very important, but local people aware about their water resources, about their problem, how they participate in the Guarani discussion, aquifer, or some actions done by government.
The different projects have different levels of decisions and different scales. When it comes to a smaller scale, in terms of deciding urban infrastructure or every city in this region, they have to have a plan for the urbanization and for the water use. On that particular level, people are accepted to bring their opinions, and also that very sound maps are produced on that level. And in fact, the participation here in this region is very high. So just to give an example, 2 weeks ago, the Geological Survey of Brazil sent 4 technicians to work with Uruguayan people on a pilot project in Uruguay without any support from any international organization. And it could be the opposite way around, so that in 2 weeks we are getting a colleague from Argentina who is bringing a gas extractor to help us in taking measurements, to taking samples for Krypton 81. So this is the way we try to work together. And Leticia and Geraldo, they are very good friends. And I mean, not only they, but many, there is a group of, a large community of people that are sharing information and working together. And this is a very, very positive outcome of the cooperation that was initiated by the World Bank, OAS, the agency, UNESCO. So, and we can do by ourselves, but when the cooperation comes and gives us support or bring a new technique, it's very welcome, and we can move forward. And Martin told about Arcal. Because of Arcal, Brazil was able to build a monitoring network for monitoring isotopes in precipitations. So this is another very good example. So the whole community was expecting Brazil to have this data to corroborate climate change models. So what's about the rainforest, the water, the humidity that is produced in Amazonas? Does it has any effect in the center part of Brazil? So we can corroborate all those theories by using isotopes in rain that came from an Arcal project. So
thank you so much. It just last question, because we have finishing, because you're from Brazil, yeah? And we know where the next COP30 will be
Sure.
in Brazil. So I would like to ask you here, please give us some secret information. Do you plan to present Guarani Aquifer a successful
Yes.
case on COP?
Yes,
the
yes,
next
it
COP?
probably is going to be presented. And also, there is a new JEF project going on the Amazonas region. It's a transboundary groundwater project funded by JEF with PNUMA, or has an implementation agency. That is going to be also a hotspot. Lots of information about those GF projects going on the Amazonas region. I tell you, come to Belém. Belém is going to be lots of fun. It's not cold like here in Azerbaijan. It's going to be very, very, very hot. So we are going to sweat, and we are going to drink and eat amazing food, fishes from the Amazonas River. I hope that the city gets prepared for, in terms of infrastructure, to host you. But I'm sure they're running and to try to fix it. But probably most of you, I think you are going to ask for Airbnb places because the hotels are going to be crowded. So if you try to go, try to organize as soon as possible, but don't, just go. It's going to be a very nice experience from this very exotic place in this Amazonas biome.
Roberta, thank you very much, and special thanks for joining us in person also from the long trip what you did to come here and share your amazing experience in person and to help us to organize this event. Thank you so much.
It's a pleasure. Thank you. Thank you all.
Thank you. We are coming close to the end of our event.
If there is any question,
If there is any question, one, two questions, what? Okay. Please, can you introduce?
Greetings. I'm Jonathan Quebman with RTI International. I'm a scientist, a hydrologist, more on the surface water side. I have roughly 47 questions, but we'll try to...
we can have coffee afterwards.
We could have coffee afterwards. Yeah, but I just, in general, I'm curious about, the programs that have been developed, and would you describe in the transboundary water management side that it's sustainable, or it's equitable, or it's both through this data?
This is a very good question, and I think that the data that we have, they are robust enough to build something very interesting and very equitable and sustainable. The challenge is if we are going to really get the message through, and if the subnational water management institutions, they are going to be mature enough to understand what we are talking about and to transfer it into reasonable tools and laws and permits. This is the challenge. So right now I see there are places where people are aware that there is a mining going on, but I see in the other hand I see places with a very, very huge rising demand for using that pristine, very old groundwater, for example, for irrigation schemes, for soya, for sugarcane, and for other kinds of crops. And that brings us a question. So how should we do about this? Who's going to take the decision? So again, the struggle and the challenge is to get everybody together, to make them understand this is a very old groundwater, and we have to look into integrated models in terms of getting water from shallow water, perhaps to do the irrigation scheme, and let this groundwater for strategic and more for the population when the time comes. But it's a big challenge. This is not the end. This is just the beginning. So there is lots of more that should be done, and we have to do.
So thank you very much. And to close the event, I would like to thank all participants and to give the floor for closing remarks to our Director of Technical Cooperation, Martin Krause, for 1-2 minutes to share positive feedbacks.
Yeah. Thank you. So what is the connection between the Guarani Aquifer and the COP29 and the climate debates that we are having here? Here and over there in the main room? What is that connection? Connection is obviously that water is a scarce resource, fresh water is a scarce resource, and will increasingly become a scarce resource. So in the national adaptation plans, the so-called NAPs, that countries are submitting, also in the NDCs, the plans that countries are submitting for both climate mitigation and climate adaptation, water, in the context of climate adaptation, plays a very, very important role. Water for irrigation, you have mentioned, Roberto. Fresh water, for drinking in the Sahel, where we have been working. It's very, very obvious, drought and dry conditions and erratic weather patterns, they impact on water resources. So precision science is what we need to better manage the available water resources. You have shown a very powerful picture, Roberto, 1976. What was the understanding of the aquifer in 1976 using unprecise science versus after isotopic techniques and all of that came in, you showed a map of the understanding of the aquifer and using the precision science. And that is the connection. We need to know much better what our water resources are, how they look like, and if we are over-exploiting them or not, if we want to have meaningful adaptation strategies that need to be reflected in the NAPs, in the NDCs, and so on. And that is the connection between that work that you are doing there and what is being debated over there. Thank you.
Thank you very much. Thank you all for your participation. Thank you for our audience online. Thank you again. So have a nice afternoon.